All right, guys. Welcome to reading Weld detailed drawings. This will be Module 2 in WT73. Okay, upon completion of this module, you will be able to identify and explain Weld detailed drawings, identify and explain lines, material fills and sections, identify and explain object views, identify and explain dimensioning, identify and explain notes and bill of materials, interpret basic elements of a welding detailed drawing, sketch or draw basic weld drawings. And the performance task is draw or sketch a welding drawing based on a given image or object. Okay, weld detailed drawings. The most common drawing used by welders is the welding detailed drawing, which generally depicts the weldment that must be fabricated and the pieces to be joined by welding. The parts are drawn, assembled, as they will appear after welding. Except the welds are not shown. Weld symbols show how the pieces are to be joined, much like the examples shown on this slide. Okay, here's a drawing that gives us all the dimensions of how it's assembled, so that we know where to place each part. And as you can see, it gives us the weld symbols, as well as the placements for each piece, the diameters of the holes to be drilled, and everything that we need so that this part could be assembled properly. Okay, the assembly drawing shows the completed and assembled object. Its main purpose is to show how the parts are assembled in relation to one another. So as you can see in this assembly drawing, we've got everything in place with weld symbols to show how everything goes together. There's actually no dimensions on this one, but we do have all the other information we need as far as where everything has to be welded and how everything is to be oriented. Detailed drawings of each part are then provided. The detailed drawing contains all information necessary to make the part. So if we look, these detailed drawings are the detailed drawings for the part, or the detailed drawings for the parts that are used for this assembly here that we see on the previous slide, on slide 5. Here's some different types of lines, depending on the different options you're trying to show. So object line or outline, hidden line. So we see that in the previous slide when they show the pictures of the tubing, or the views where you can't see all of the part. It shows that there is a cut or another part there. Center line, that gives you the center of a hole, the center of a weldment or a part. Dimension lines, leader lines. If you guys take the AET 15 AutoCAD class, you'll learn more about these different line types and their uses. Okay, objects lines are a thick line that's visible edges of the part, also called a visible line. A hidden line. Remember, guys, anything that's typed on these slides is really important to pay attention to. If I change the color and underline it, it's probably extra important. A hidden line is a medium broken line made up of evenly spaced dashes that is used to show edges that are not visible. Center line is a thin broken line made up of short and long dashes that is used to show the center of holes or other objects. A dimensioning line is a thin line with arrowheads that shows the extent of the dimensions, but is broken by the dimension number. Extension line, a line used with dimension lines. It extends from a point on the object to the dimension that applies to it. A leader line is a thin horizontal line with an angled arrowhead at one end used with a note or dimension. The arrowhead points directly to the surface of the note or dimension to which it applies. Cutting plane lines, a line used to show an imagery cut has been made through an object. It has a heavy line that can be made up of either of the following: a series of one long and two short dashes. Short lines with arrowheads are on both ends of the line. The arrowheads point in the direction in which the section should be viewed. Short break lines, a thick, solid, irregular drawn freehand to indicate the part or the object has been removed or broken away, used to conserve space or show internal detail. A long break line is a thin, solid line with zigzags inserted into several places. It's used to show a section of the object has been removed to conserve space on the drawing. Okay, here's some fills. When we use a cutting plane line, where we actually cut a part to show internal detail, the different crosshatch that's shown here will be used to show that we've actually cut the part in half. Okay, a solid round break and a pipe or tubing break are represented by thick curved lines that loop back on themselves. The loop is filled with a material symbol to indicate an internal surface. Breaks are used to show where a section of the object has been removed to conserve space on the drawing. So as you can see, the top being solid and then the bottom being pipe or tubing, there's actually, we can kind of see the internal surface also. All right. Here we're looking at two different types of material, angle iron, channel iron. We're showing a break to show a cross-sectional detail of the material. The isometric view shows a three-dimensional picture of an object. Isometric portrait view is an excellent way to show what an object looks like, but it is a difficult view to use when providing details such as dimensions, hole locations, sizes, or angles. For this reason, the isometric is generally not used on detailed drawings. Multi-views are developed by a process called orthographic projection, and they are generally used to detail drawings. The front view is selected as the view that best represents the shape of the object, okay, as we can see here on slide 13. Okay, and this is just a showing the part that we saw earlier on in the PowerPoint, giving us showing the isometric view and then taking it to an orthographic projection that shows all the details. Okay, a full section or cross section of an object that is used to show internal detail that would not normally be visible. A cut line is used on one of the complete views to indicate where the part has been cut or sectioned. Okay, and then the arrows that show there on the right that point to A, that actually shows in which way we're viewing it. So we're actually viewing it as if we're looking to the right of A towards the letter A. Okay, dimensions identify sizes. Drawings must have dimensions if the object shown is to be fabricated. The two basic methods of dimensioning a part are conventional dimensioning and baseline dimensioning. A reference dimension such as the 1 3/4 inch dimension in parentheses of the drawing is obtained by adding or subtracting other dimensions to be found on the drawings. So the reference dimension actually may not be given based on the fact that we have the overall length dimension and we have the dimension of the two parts above it. It may not actually be given at all on the drawing. Okay, this is just showing that a drawing could be scaled. We're not going to have paper as big as some of the parts we fabricate, so we'll have to scale it. This is an example using a 1/2 inch equals an inch scale. Usually it's much larger than this, like 1/2 inch equals a foot, 1/4 inch equals a foot, and so on. Here's some location dimensioning so that we can locate the center of that hole. Okay, the hole is to be drilled only partway through the object, which is called a blind hole. Then the depth is also given, as we can see there on the bottom right, where it says blind hole. Gives us a 1/2 inch diameter with an 1.5 inch depth. And then they've also cross-sectioned for us so we get a little more detail. You can see it's an 1.5 inch depth of straight wall 1/2 inch. It does not count the taper at the end of the drill bit. Okay, countersunk holes. We now have degrees given for the countersink and also indicating that it's 2 holes. And a counter bore is just a larger bore around the hole to recess a fastener. Okay, bevel and angular dimensions. Okay. When the ends, sides, or corners of an object are to be rounded, a radius or arc is shown in the dimension. Should remember radius from high school geometry. It's just the dimension from the center of the circle to the outside edge, or half the diameter. Tolerance is an important part of dimensioning because it identifies the variance in size that a part is allowable. We talk about this a little bit when you guys do the cert plates. If you remember, there's a mark on the saw that I have you guys place the end of the plate on to cut, because that mark is pretty much plus or minus a quarter inch of what we're looking for our plate size. And so that's a tolerance that plate is okay if it's 3 3/4 of an inch or 4 1/4 inch. You know, that gives us a little bit of leeway in how accurate the part has to be. Okay, items typically found in general notes include the following: references to specifications, procedures, or other notes, identification of work responsibility, surface finish requirements, smoothness, type of finish, special handling requirements, material requirements such as specifications, grade, and class, special assembly requirements. Local notes are used for items such as the following: thread, fastener type and size, location of special items, parts to be supplied by others, reference to details on another drawing, elevations, special treatment or finishes, drilled hole size. A specification is a note that provides a detailed description of requirements for the type and size of parts or materials required. Bill of materials, also called a parts list or schedule of parts, is a list of all the parts required to fabricate an object. All right. Well, it looks like that will conclude the weld detail drawings section. All right.